I am Srihari from EDS Technologies, and I thank you all for taking your time out and joining this webinar on streamlining design process and increasing efficiency with CATIA Automation. I would like to begin the webinar by giving a short introduction about our company, EDS Technologies. We are one of the largest technology solutions providers in India with more than 30 years of business transformation experience. We help transform businesses by enabling adoption of virtual twin, geospatial analytics, and 3D printing. EDST has introduced many technologies like 3D printing, VR, digital manufacturing, etc. for the first time to Indian customers and has established itself as a trusted partner for more than 2,000 organizations across various industries, including automotive, aerospace, defense, industrial equipment, mining, and more. EDST has dedicated regional teams reinforced by domain and functional consultants. We are backed by strategic alliances with global leaders, pioneers in their respective technology areas like Dassault Systems, who are our strategic business partners. We have a widespread presence over 11 offices across India with our headquarters in Bengaluru. We are an end-to-end technology solutions provider to our customers. Our speakers for the session will be Srihari, Ashish, and Ratan. Srihari has over 19 years of experience in domain of engineering services. He has delivered automation solutions in PLM administration. He is presently leading a team for providing automation solutions in CATIA V5 and 3DEXPERIENCE. Ashish has over 6 years of experience in technical support, technical troubleshooting, application administration, e-learning, and macro development. Ratan has over 3 years of experience in product design, development, standardization, consulting solutions, process optimization, and automation. We start with knowledge-based engineering. Knowledge-based engineering is the ability to create design considering a company's existing knowledge, but also company standards and international rules. Here, knowledge is captured and formalized so that it is directly available to the user with certain level of automation. Knowledge-based engineering enables quick function-driven designs, which leads to more time for innovation. It helps us arrive at a solution first time right consistently every time, and this helps to avoid expensive redesigns. It reduces time on standard tasks, thus leading to increase in overall productivity. The CATIA Knowledge apps helps users to automate product definition, capture corporate engineering knowledge, ensure compliance with corporate standards, guide and assist users through design tasks. They also help us in preventing costly redesigns. These are some of the repetitive tasks that are good candidates for automation. Title block generation, revision block with history, user-defined properties to part and product, BOM creation, bumper gap check, ballooning, and weight calculation. Now my colleague Ashish will share some real-world examples that have been delivered in the past.
Thank you, Mr. Srihari. Good evening, everyone. So let us explore some of the delivered use cases. Well, this requirement was from aerospace company where customer wanted to create user reference properties for the part and the product, and later same properties were to be mapped to the title block. So let's see the demo of the requirement. So let's open a part. When you go to properties, you can see the standard properties available. Now let's run a macro. When you run a macro, the user form will be prompted. Enter the details and click OK. Now, if you go to properties, you can see that added user reference properties to the part. Now click on X button to create the drawing document. So select the sheet size and the standard. Define the drawing document name. Now specify the location to save the drawing file. Now let's create a view in order to create link between 2D and 3D. Now let us see how to update the properties with a single click of a button. So you can see that properties of title block are updated. Similarly, we can create the revision block. Enter the details. Revision block is created. We can also update drawn by and review by selecting the respective option. Similarly, we can create multiple sheet and we can update with a single click of a button. So defining 10 number of properties to a part of product will take 25 minutes as a traditional method, but using automation, it can be achieved in 2 to 5 minutes. Similarly, creating the drawing and updating the parameters and the properties will take 5 to 10 minutes and 45 to 50 minutes both. And using automation, it can be achieved in 1 minute. So the total duration for the traditional method used to take 70 to 25 minutes, but using automation, it can be achieved in 4 to 7 minutes. So the average time saved for this automation is 90%. Moving to the next requirement, bomb extraction for an automobile industry. So beside the mechanical properties like mass, density, surface area, there are some calculated properties that are incorporated in this bomb like material type, paint area, paint thickness, and total center of gravity. So basically, this automation was created for bumper panel assembly, but due to customer proprietary data, we are presenting this demonstration on a different assembly file. So let's have a demo. So bomb is extracted. So this traditional method, let's take 200 parts, would take 800 to 1000 minutes, but using automation, it can be achieved in 1 minute. So the overall efficiency gain through this automation is 100%. Moving to the next requirement, creating the drawing table in the drawing document from the Excel data. So there will be two tables generated with a different orientation. Let's see a demo. When we run a macro, it will ask us to select the Excel file. Enter the path of the Excel. So once you give OK, it travels through the Excel. So this Excel has 56 columns and approximately 4,000 cells that needs to be entered manually in the drawing document and maintaining the font orientation as in the Excel. So once the tables are created, it can be aligned by the user. So this traditional method used to take 30 hours, but using automation, it can be achieved in 2 hours. So the overall efficiency gain through this automation was 93%. Moving to the next requirement, arranging the overlapping balloons. Let's see a demo. So you can see assembly. Let's generate the numbering. Now let's create a drawing document. Now let's generate the balloon. Now let's run a macro. So the automation creates the copy of the current view and declutters the balloons from the current view to the copied view. The same process can be repeated if the declutter of balloons are required. So this traditional method used to take 5 to 10 minutes, but using automation, it can be achieved in 20 seconds. So time saved from this automation is 94%. So moving to the next requirement, whole axis alignment checking and diameter mismatch. So let's see a demo. You can see an assembly with the adjacent multiple holes, which has axis alignment issues and diameter mismatch. Now let's run the macro. So you can see the two color. The red color represent the axis alignment issues and the yellow color represent the diameter mismatch. You also get the result in the form of Excel. This facilitates the detection of quality issues before the product is delivered. Moving to the next requirement, gap check, to check the minimum gap between the two adjacent panels. So there are two surfaces and the guide curve. Along the guide curve, normal planes are created. The intersecting surfaces are projected onto the normal planes, and this gap between the intersecting surfaces is measured and written. So let's see a demo. So select the inputs. So keep the measure option enabled. We can also increase the pitch distance to get the better consistency accuracy gap check. This works like a quality check tool, which is performed after the assembly to check the gap consistency. So this traditional method used to take 60 minutes, but using automation, it can be achieved in less than 3 minutes. So the overall productivity gain through this automation is 95%. Moving to the next requirement, paint area surface calculation. So let's see a demo. So you can see an assembly which has multiple machine holes and the overlap surfaces. So these machines holes and the overlap surfaces are to be excluded from the painting. So go to properties. So you can see the surface area. Now let's run a macro. So you can see the surface area, which is 10% lesser than the standard value. So the productivity gain in this automation is in terms of cost, which is 10%, unlike previous cases. Now I'd like to hand over to my colleague Ratan for the further demonstration. Thank you. Over to you, Ratan.
Thank you, Mr. Ashish, for the presentation. Let us see a few more delivered automations in CATIA V5 and 3D experience as well. Here we have a customer's scenario from automotive domain. Here the customer requirement is to create a tow hook covered with the mounting features and the bumper cutouts. Here we consider only two inputs for this automation. One is tow hook cover shape like circle, square, etc. The another one input we consider as a A-class surface also automotive. Let us see how the automation works in a quick demo. Here are the areas we can see tow hook covers. Let us open the input file. As I mentioned, we are only consider two inputs. One is tow hook cover shape and the surface. So automation prompt for the user to select the input. First we are selecting the circle and the surface. Now we are invoking the automation and we are selecting the input. In a single click of a button, we can able to get the output. So on top of this automation, we can able to configure the design as well. We can able to see the slot and arrow features are getting changed across the tow hook cover. With the help of this design table, we can able to vary the input values as well. According to that, output will also change. The same automation can be done in 3D Experience CATIA as well. Here we consider set of inputs and we are invoking the automation and we are carefully selecting the input in a single click of a button and we are getting the output. Here also we have done some configuration on the output with the help of the design table. By varying the configuration, we can able to see the slot and arrow features are getting changed in positions. Here, the average time taken for this activity to do it manually by the customer, it would be 1.5 to 2 hours. The same activity can be done using this automation within 4 to 7 minutes. The average productivity gain would be 94%. Here we are consider only creation of one part document. Similarly, the time saved for much more components will be exponential gain. So here we have a one more customer scenario from automotive customer. And the customer requirement is to create the milliwave radar cover with the mounting features. Here also we are consider the bumper surface as an input, and these kind of a components can be seen in premium models of cars and trucks. Let us see a quick demo. Here MWR are usually mounted on the car surface in front fascia and the rear fascia. Here how it schematically looks like. So here we are selecting the input file and we are initiating the automation. With a single click of a button, we can able to see the results. And we have done some parameterization on top of this in order to vary the width and height of the MWR cover. You can able to see the changes we are able to done. So the same automation can be implemented in various areas such as fuel tank cover, charge port cover, and the sunroof cover. So the same automation can be achieved in 3DEXPERIENCE CATIA as well. Here also we consider the set of inputs and we are initiating the automation. And with a single click of a button, we are selecting the input and we can able to get the desired output here. So the average time taken for this activity to do it manually by the customer, it would be 1.5 to 2 hours. The same activity can be done using this automation less than 4 to 7 minutes. Here we can see the average productivity gain would be 94%, which is very significant. And here we are just consider for creating a one part document, and similarly the time saved for creation of such more milliwave radar cover would be more exponential gain. So we have one more customer scenario from automotive customer. The requirement is to create the trimline generation for automotive panels. Here we are consider the panels as an input and the output we are getting through as a generated line. Let us see a quick demo how automations work. Here automation prompts the user to select the curve and automation gives the overall length. So with that length, we can able to decide the number of pitch length is required based on the requirement, and prompts for user to select the surface. And with the execution of this macro, the end results you can see in form of streamline. It represent in green color. The same activity can be replicated in 3DEXPERIENCE CATIA as well. Here it is giving the overall length of the curve and it allows the user to enter the desired pitch length. And selecting the surface. With that, we can able to get the end results with a single click of a button. Here, the productivity gain will be even more higher for the pitch distance as low as 2 mm. Here we are, the average time taken for this activity to do it manually by the customer, it would be take 60 minutes. The same activity can be done using this automation less than 10 minutes. The average productivity gain would be 95%. And here we consider only single panel. Similarly, we consider for multi panels, the time saved will be exponential. The next customer scenario is from automotive supplier. Here the requirement is to part coloring the component which is there in assembly to distinguish between them for a post analysis process. Here we consider the leaf spring. Let's see how the automation works through a quick demo. And these requirements came exclusively for 3DEXPERIENCE CATIA. Here we invoking the automation, and with a single click of a button, you can able to see the various different colors for each part and the component in an assembly. The actual customer part is a clutch plate with an 100 number of 0.5 thickness of a shim plates. Since it's a proprietary data, we are replaced with the leaf springs here. So the traditional method of taking the time would be 40 to 60 minutes by the customer, and with the same activity can be done through this automation between 2 to 3 minutes. The average productivity gain would be 94%. And here we just consider 100 parts in an assembly. Similarly, the larger assemblies, the time saved will be even more exponential. Now my colleague Srihari will take over next.
Thank you, Ashish and Ratan, for the wonderful presentation. These are some of the customer references and past deliveries we have provided in order to improve the productivity, reduce human error, and these are the typical benefits of CATIA macros. So this macros help us in enhancing the productivity, and this improves the resource availability for higher value-added activities. And this also reduces the reworks and any scraps that are a result of any wrong entry due to human error can also be eliminated because of CATIA macro. So thus reduced scrap results in reduced inventory that is maintained to compensate for this scrap, and this results in increased scheduling and production efficiency, and this helps in increasing the overall customer satisfaction and profitability. I would like to thank speakers for delivering this very informative webinar. I'm confident that it was helpful to our audience as well. I would like to also thank the audience for taking their time out and joining us for this session. If you have more questions related to the subject matter or any other requirements, you can always connect with us. Our details are displayed on the screen right now. You can reach out to us anytime and we will be happy to address your queries. Please do keep an eye out for our upcoming seminars and webinars. You can follow us on our social media handles. Thank you once again for joining us today.